All right. Hi, guys. So my name is Catherine Miller. I go by Kate, and this is going to be my science community project. So I don't know about you, but we live in a very stressful world. It could be very difficult to handle your home life, your work life, and your school life, or whatever else you have going on. And sometimes could be very overwhelming. Um, and I sometimes, I don't know about you, I have a hard time handling it. So today we're going to be going knowing now, we're going to be going over a study called Stress Fitness, a neuroscientific approach to building emotional resilience. Okay, before we get started, we need to talk about, give some background information. What is stress affects the whole spiel. So, stress is a threat mechanism developed in early childhood, designed words to protect us and allow us to adapt to our environment. Stress triggers or exacerbates different mood, affective, and associate and addictive disorders. A good example of this is major depressive disorder, affects over 300 billion people worldwide. That's a lot of people, and that's just that one, not including everything else. If it's such a big of an issue, how do we deal with it? So we deal with stress by building resilience. Um, think of stress as an actively dynamic driver that interacts with our nervous system, a stress response systems. Um, yeah, stress impacts our brain and behavior due to the duration, intensity, predictability, and controllability of the stressor, meaning that too much stress can create a new homeostasis, and which is an autistic load, and degrades our physical and mental health. So, say your homeostasis is right here, right? You go through a lot of stressful, like chronic stress situations. Your new stress level's here. So, instead of being able down here and be able to relax, you're going to stay stressed out because your system is shot, basically. And that, like I said, that affects your mental and your physical health, and that severely degrades it. Stress inhalation is basically a way to build resistance during exposure, effective immunity. Stress resistant algorithm, the SRA, is basically determines how we respond to stress. It's driven by pre-existing inputs. This could be your genetics, your experiences, and your coping strategies. Do you handle it? Do you, run from it, or do you handle it straight on and do you find a way around it? It's basically what do you do about it? Next, let's talk about the background of neurobiology of stress. Stress triggers our autonomic nervous system and our LHPA axis. Our autonomic nervous system is a rapid wave that triggers epinephrine and norepinephrine to be released into the heart. It changes heart rate and blood pressure. The LHPA axis is a slower neuroendocrine wave where PVN releases corticotropin release factor, signaling the pituitary to make adrenal cortex release cortisol. Cortisol is basically like your stress hormone. It's and so basically, cortisol mobilizes energy, creates alertness, and temporarily stops non-essential processes to allow you to act faster. Unfortunately, too much stress could damage this stress response. That's why we have something called the negative feedback mechanism, negative feedback loop. It's basically a way of if you're up here stressed out to bring you back to the homeostasis. Some examples could be delayed geometric feedback, circadian and baseline tuning, fast non-geometric feedback. Neuroplasticity is a brain's ability to structurally and functionally adapt. Methods. So this was a secondary source paper, meaning there are several models, theories, and other findings from other researchers and research papers that it's just a combination of it in this paper instead of it being a primary source and them discovering it all on their own. So let's talk about results. I separate a lot of the results in different sections because it's just a lot of information. So here we go. Resilience. What they found about resilience is it's a combination of protective factors that helps us adapt to hardship. Resilience training is taught through exposure to moderate stressors or stress inhalation. A good example of this they had in a study is they would compare holding rat pups when they're in a neonatal period or neonate period. I think it's what it was called. Um, when they were little, held them, had that little bit of stress, and then put them back. And when they were older, they were able to handle stresses better because of this. Some models state that good stress promotes resilience and are associated markers with neuroplasticity. Basically, what this means, good stress helps with your neuroplasticity. And it was definitely a common factor across several different stress models and studies throughout this paper. Chronic and severe stress damages your neuroplasticity and impairs emotional and cognitive functions. The next section is perception and social support. Self-efficacy is basically what they found about it. It's a person's conviction that they can influence or control a given outcome or situation. Basically, what this is saying is, someone who has a positive mindset that, it will work out, I will get through this, that it will be okay, that they're a lot more resistant to stress. They can handle it a lot better, say, than someone who thinks that the world's ending. Perceived social support and presence of quality relationships are critical resilience factors. So, having a good support system helps you handle stress better. Social buffering was another thing I also talked a lot about. And this is basically talking about having a social partner present during a stressful situation can dampen the stress responses in your brain, making it a lot easier for you to handle it. It's more comforting. They also found that social isolation is a severe stressor that alters the brain growth factors, signaling pathways, and stress-related molecules. Next is changes to neurology because of stress. Neuroplasticity, epigenetic mechanisms, and multiple cell types contribute to resilience as an active, ongoing, dynamical process. Many and his colleagues discover that high levels of maternal care induce the following changes enhancing negative feedback. So basically, what this is saying is having a lot of maternal care and having that comfort basically allows it easier for your negative feedback to bring you back to that homeostasis. Neural reorganization leads to gene regulation, shifts in neuroplasticity, and recruitment of distant brain networks. Dysregulated LHPA axis contributes to anxiety symptoms. So, like we said earlier, this axis creates your cortisol, creates that stress response. And so if that axis is dysregulated, then you're gonna be stuck in those anxiety symptoms and those the world's ending, I'm freaking out feelings, right? Genetic protection against stress can be overridden during severe stress. So basically what this means is that some people are genetically it's easier for them to handle stress. And then some people just have a predisposition. They're just going to handle stress worse because of their genetics, because of how they're made. And but if you're in severe stress situations, basically genetic factors don't. It could override it. If you're in severe stress, it doesn't matter how good your genetics are, you're gonna be stressed out. Conclusion. So while researching this paper, there was mainly two big weaknesses I found. Number one is how dysregulated it was. Instead of having all the information organized by the abstract, the background, the results, it was just all mixed in. And I don't know about you, but that makes it really hard for me to be able to understand what I'm reading when I'm constantly, instead of just going down like this, I'm like, like it's not it makes it a lot more difficult to read. The second weakness I found is there's not enough details on what study they're pulling from. So there's a lot of studies or a lot of information that was given that was just said that several studies found that X, Y, and Z. Instead of being like, oh, this author from this study found this out, they just omitted where they got the information from, basically. But ultimately, addressing the world's mental health crisis requires reframing resilience as an active, highly adaptable biological system. If we could shift our focus of neuroscience to stress fitness and building up that tolerance and other preventable measures, researchers and clinicians can harness neuroplasticity to adjust individual stress responses. Incorporating these in our public health initiatives we can create a more proactive way of building resilience, mitigating risk, and transform how we manage stress-related disorders. Thank you and have a great